Hi everyone, my name is Allison Miller and I am one of the Rosalind Franklin Physician Assistant students who completed this study. I'd like to acknowledge my research partners listed below. The title of our study is The Reliability of Segmental Spinal Motion Analysis Using Surface Topography. Here are our disclosures. So why did we want to measure spinal motion? There have been many studies focused on gait, however the motion of individual segments of the spine during gait is not well understood or studied. We thought that if we could better understand the motion of individual portions of the spine during gait, we could improve treatment options for spinal pathologies such as scoliosis. So why is surface topography a good way to measure spinal motion? 1, it does not emit radiation, so it's safe to use on everyone. And 2, it assesses motion of the entire body in addition to the spine, which allows for understanding of how spinal motion relates to other joints. So our official research question is, can surface topography reliably measure segmental motion? As for methods, our subjects were 17 healthy young adults with no history of spinal pathology. We used the Deers 4-metric motion lab to retrieve our measurements. As for data collection, subjects walked in comfortable walking shoes on a treadmill at a speed that they chose as their normal walking speed, while the surface topography scanner measured movement of their spine. 3 measurements were taken, each lasting 5 seconds to capture approximately 15 gait cycles total. The 3 gait cycles were then compared to each other to see how much variability in spinal motion there was between them. This is a sample of the data gathered from the machine, so you can see just how much information we're given. This is a sample of what our results looked like for just one subject. So you can see that for each vertebra from T1 to L4, we were given the max rotation to the right and the max rotation to the left, and then the movement overall. These were then averaged together to give us the maximal movement for both the thoracic and lumbar regions. Overall, we found that the Cronbach's alpha was 0.926 and the intraclass correlation was 0.796, which shows that surface topography provides reproducible data for dynamic segmental spinal motion, which further suggests that surface topography is a good way to measure spinal motion. So to wrap up, dynamic segmental spinal motion adds data that static images cannot. With static imaging, patients may be unconsciously altering their natural standing position. So motion imaging provides the ability to observe changes in the spine with gait. We can see the degree of vertebral rotations and changes in spinal curvature throughout the gait cycle, which enables clinicians to better determine the effects, benefits, and drawbacks of potential treatments. Reliability would also be important to measure, which would require comparing segmental motion analysis of the spine to another modality such as fluoroscopy, but this would be difficult to do because of the radiation exposure. Here are our references. Thank you so much for watching. Please let us know if you have any questions. Have a great day.